Welcome to Module 2, Lesson 6, Solving Systems of Linear Equations. In the previous unit, we looked at the graphs of linear systems and where the solutions lie on the graph. In this lesson, we'll work on solving systems of linear equations algebraically. So I have a systems of equations here, and I want you to ask yourself, what do you notice and what do you wonder? Well, you might notice that both of the equations look very similar with just minor differences. So both of them contain the term 3x. But for the y term, the first equation has positive 2y and the second equation has negative 2y, right? So we have one term that has the same coefficient, same sign, and another term that has the same coefficient, different sign. And take a look at our constants, right? We have positive 4 and negative 4. So almost the same number, just opposite signs. Also, I want you to please recall from the previous lesson that the solution to a systems of equations is the point of intersection, right? So it's a point on the graph. It's an ordered pair that has an x and a y value. I want you to keep that in mind as we learn how to solve systems algebraically. So first, we're going to start with the elimination method. And when using the elimination method, we could either add the equations or subtract the equations. The elimination method, in my opinion, and it's just my opinion, is my favorite method of solving. I noticed that many students prefer substitution. I think substitution is a lot longer. And the elimination method is actually so beautiful, and I'll show you why. So the point of the elimination method is to eliminate one of the variables to solve for the other, right? If we're dealing with x and y, we can't solve for either of them. We have to get rid of one of the variables, either x or y, in order to solve. So when we have a term that has the same coefficient but opposite signs, we can add the equations together to eliminate them. So in this case, positive 2y and negative 2y will cancel out because when you add them together, they combine to 0. So again, when you have a term with the same coefficient, opposite signs, you can add the two equations together to eliminate that variable. So positive 2y and negative 2y will cancel out. And if you notice in this case, so will positive 4 and negative 4. We'll add 3x and 3x together, and we get 6x equals 0. Now we're only dealing with one variable, x, and we can continue to use inverse operations to solve. We'll divide both sides by 6, and we get x equals 0. Now remember, now we have our x value, but we need to find our y value. So you can choose either of the equations and substitute your x value into that equation. So I chose the top one. We're going to substitute 0 for x. We get 2y equals 4. Divide both sides by 2. And we get y equals 2. So our solution is 0, 2. Now let's try subtracting these equations. So I strategically created this system of equations to show you a case where we can add and where we can subtract. Now, not all systems will be set up where you could do both, right? So you have to really look at your system and decide, do I need to add these equations or do I need to subtract these equations? So when you have two terms that have the same coefficient, same sign, you can subtract the equations to eliminate the variable. So now we're going to subtract the equations, and this time we're going to eliminate x to solve for y. So we'll do 2y minus negative 2y and 4 minus negative 4, and we get 4y equals 8. We can continue to solve for y by inverse operations, and we get y equals 2. Now, same thing, we have our y value, we still need our x value, so we'll substitute 2 for y into either of the equations, simplify, and then use inverse operations to solve for x. So let's subtract 4 on both sides. Notice how 4 and negative 4 will cancel out on both sides of the equal sign, and we get 3x equals 0. Now we'll divide both sides by 3 and get x equals 0. So our solution, which is the same as in the previous slide, is 0, 2. Notice how our solution is our y-intercept, right? Because the x-coordinate is 0. Now let's take a look at the substitution method. So there are certain cases where it might be more strategic to use the substitution method. For example, in this system of equations, we have y equals 2x minus 1 and 2x plus 3y equals negative 7. Since the first equation is already solved for y, it makes sense to just take 2x minus 1 and substitute it into y for the second equation. Right, so substituting for y, we get 2x plus 3 times the difference of 2x and 1 equals negative 7. Right, so since the first equation was solved for y, we just took 2x minus 1 and substituted it for y in the second equation. This way, now we're only dealing with the variable x, and we can solve for x first and then find y after. So using the distributive property, we get 2x plus 6x minus 3 equals negative 7. Now let's combine like terms, and we get 8x minus 3 equals negative 7. Adding 3 to both sides, negative 3 and plus 3 cancel out, and we get 8x equals negative 4. Finally, we'll divide both sides by 8 and get x equals negative 1/2. Again, that's our x value. So now what we're going to do is we're going to take x and substitute it into the first equation, right? That's the easiest one to substitute for x for because it's solved for y. Right, so we get y equals 2 times negative 1/2 minus 1, which is negative 1 minus 1. So y is equal to negative 2. So our solution is negative 1/2, negative 2. Please pause this video and work on the Lesson 6 Level 1 problems in the workbook. Moving on to our Level 2, the intermediate level. Do you remember the types of solutions that we talked about in the previous lesson? If we have two parallel lines, it means that the system of equations has no solution. If we have two lines that intersect, it means that this system of equation has one solution. If we have the same line, it means that there are infinitely many solutions, right? So this is going to be important to keep in mind when solving algebraically. We're going to take a look at some special problems that are specific to the SAT. You may or may not have been questioned this way when learning about systems of equations when you took algebra. So keep in mind that if the two lines are parallel, there's no solution. And also keep in mind, if there's no solution, that means the two lines have to have the same slope, right? If the question is asking you about infinitely many solutions, the two equations have to be the same exact line, so they have to be the same exact equation. Let's take a look at this question here. The given system of equations has no solution. If a and b are both positive constants, what is the value of a over b? So let's look at our system here. We have ax minus 3y equals 21 and bx minus 3y equals 11. So they tell us that the given system has no solution. That means both of the equations have to have the same slope. So let's solve both equations for y and put them into slope-intercept form, right? Because we need to look at the slopes here. Right? So using inverse operations, we're just going to solve for y. And the first equation becomes y equals a over 3x minus 7. So now we know the slope of the first line is a over 3. Looking at the second equation, we'll use inverse operations. And we get y equals b over 3x minus 11 over 3, right? So the slope of the second equation is b over 3. So how is a over 3 and b over 3 related? Well, we know that these two lines are parallel, which means they have the same slope. So that means a over 3 is equal to b over 3 because they must be the same. And if a over 3 is equal to b over 3, that means a is equal to b. Now, if a is equal to b, then a over b has to equal 1, right? Anything divided by itself is equal to 1. Right, so the key takeaway from this problem is that they tell you that there's no solution, so you have to realize that that means both equations have the same slope, and then you would find the slope of each line and set the slopes equal to each other in order to answer this problem. Please pause this video and work on the Lesson 6 Level 2 problems in the workbook. Moving on to our Level 3, the expert level. We're going to look at a few problems that involve problem solving with systems of linear equations. In the systems of equations, w is a constant. For what values of w will the system of equations have exactly one solution, xy, with x is equal to 1? Okay, so we know that there's going to be exactly one solution. And they give us the x value. So we're going to start with that. We're going to substitute 1 for x for both of the equations, right? Both of our equations here contain x. So we substitute 1 for x into both of the equations and simplify. Right? All we're doing is multiplying by 1, simplify both equations, and we end up with this new system, w plus 2y equals 3y plus 4, and 8 minus y equals negative 2y plus 5. So now we've gotten rid of x, right? And we can solve for y. So we're going to solve for y. So here's the system that we're working with now, right, after we substituted 1 for x. Again, we have w plus 2y equals 3y plus 4, and 8 minus y equals negative 2y plus 5. So we're going to use the second equation, 8 minus y equals negative 2y plus 5, to solve for y, because it's the only equation out of the two that only contains y, right? The first equation still has w, so we don't have enough information to solve for y in the first equation. So using inverse operations, we end up with y equals negative 3. So now we have our x value, 1, and our y value, negative 3. So what we're going to do is we're going to substitute negative 3 for y and solve for w. So in this case, we can only use the top equation because the top equation is the only equation that contains w. So substituting -3 for y, we get w plus 2 times -3 equals 3 times -3 plus 4. Let's just simplify. We get w minus 6 equals -9 plus 4. Combining like terms, we get w minus 6 equals -5. And then finally, using inverse operations, we get our answer, w equals 1. Let's take a look at a question that involves infinitely many solutions. So consider the system of equations where a is a constant. For which value of a are there infinitely many solutions to the systems of equations? So we have a times the difference of y and 1/3 plus x over 2 equals 0, and 3y minus x minus 1 equals 0. First, we're going to put the equations in slope-intercept form. So remember, if there's infinitely many solutions, both equations have to be exactly the same. They will have to have the same slope and the same y-intercept because it's two of the same line lying on top of each other. So we'll use inverse operations and we'll put the equations in slope-intercept form. Right? All we're doing is simplifying using the distributive property and then inverse operations. Right? Now we'll divide by the coefficient and we get our system of equations in slope-intercept form. Right? So we have y equals -x over 2a plus 1/3 and y equals x over 3 plus 1/3. So notice, after we solved each equation for y, our y-intercepts are already the same, right? The y-intercepts are both 1/3, right? So now we just have to look at the slopes. The slope of the first line is -x over 2a, and the slope of the second line is x over 3. Now we know they have to have the same slope and the same y-intercept. So all we're going to do is set the slopes equal to each other, right? -1 over 2a equals 1 over 3. Right? The slope of the first line is -1 over 2a, and the slope of the second line is +1 over 3. So we set the two slopes equal to each other, and we'll just solve for a. So 2a equals -3. We divide both sides by 2, and we get a equals -3 over 2, which is choice A. Please pause this video and work on the Lesson 6 Level 3 problems in the workbook. Once you finish the problems in the workbook, please stop this video and move on to the next one for Lesson 7.